The scientists at CERN have been lost in a sea of data over a decade. The Large Hadron Collider accelerates protons against each other 1 billion times a second in a cascade of particles. Implicit in such a mess is a phenomenon that is so uncommon that it may take 1 trillion collisions before it occurs. They are like trying to find a single grain of sand in the Sahara, and the grain may be the key to the universe itself. There's something extraordinary must have occurred. In 2025, the quantum project of CERN tacitly attained a milestone. Researchers found a new ally in the form of quantum computers instead of using traditional supercomputers. And what they had found was perhaps to alter the game forever. During test runs, groups would apply quantum machine learning algorithms which exploit the weird logic of qubits to seek the smallest hints of Higgs boson events. The Higgs boson naturally is the particle which gives matter its mass, the so-called God particle. Typically, its decays are hideously hard to see, but they did something classical computers found difficult, and that is to extract whispers out of the raw, these new quantum classifiers. Patterns of decay which had been practically invisible were now visible, to suggest that it is hard to listen to a single person speaking in a stadium, with a crowd screaming at the top of their lungs is an understatement. It is what discovery of Higgs boson will appear in collision data. However, today, researchers indicate that quantum computers could potentially be sensitive enough to detect that single whisper the first time ever. The revolution was not only on paper. At the beginning of the year, the scientists of CERN integrated quantum classifiers and advanced artificial intelligence. This hybrid system was able to do something out of the ordinary. It set records that found one of the uncommon Higgs decay channels, which the particle splits up into charm quarks. It is a process so uncommon, so delicate, that it has been one of the unsolved problems in particle physics. But the AI, together with quantum, hit the nail on the head. Why does that matter? The fact that every channel of decay that we discover increases our knowledge of the Higgs field itself. It is the cracking the whip of the veil of the universe one slit at a time. And in case these initial findings are valid, then it is possible that human-made machines have started exploring the beliefs of the Higgs that we have so far not seen. Consider the consequences. It was only confirmed that the Higgs boson existed in 2012, less than 20 years since. Quantum computers already are expanding that discovery, discovering new methods of tracing the behavior of the Higgs. This is not just the new tool to researchers, but a complete set of new eyes to the data, and to the rest of us. It poses an even larger, more serious question. What happens once these machines begin discerning something in the data we were not even aware of? Here, however, is the punchline. In certain of those early tests, that is precisely what appears to have occurred. Abnormalities, trends that did not fit quite into the pattern. The type of outcomes that would cause scientists to pause, look and say, wait a second. What have we here really got to see? And that's the cliffhanger. Were these aberrations merely computational glitches, products of inexperienced hardware, or the first signs of something new? The smallest footprint of the standard model physics? No one can say for sure. However, there is one fact which is definite. Quantum computing and Higgs physics already moved us to the place we have never been before. And hence the current rhetoric of God particle protocol will some voices start murmuring. Not a doomsday switch, but an indication that we have crossed over into the unknown. Since quantum computers may be unveiling the secrets of what is in the Higgs, then it may be that quantum computers are revealing us that the most fundamental of all things are more delicate, more bizarre, more surprising than anyone could dream. And this is where it becomes really disturbing, since some of such outcomes already raise questions that no one has the complete comprehension of. And that's where we turn next. When quantum computers joined in the search of the Higgs, something happened out of the blue. In some of the experimental runs, researchers found that everything did not exactly work as predicted. Not large flashy breakthroughs, but little, obdurate anomalies, little bents in the models which do not disappear upon again checking the data. Patterns which, as it were, murmur, there is more here than you thought. An anomaly in physics is never now merely swept aside. All of the breakthroughs in history, including that of relativity, as well as quantum mechanics itself, started out as something strange that did not conform to the rules. When quantum computers provide output that classical computers cannot describe, therefore, it is not a glitch that can be overlooked. It is an opening, and scientists know that they have to peep through it. The inquiry is, what is on the other side? One of them is completely prosaic. It is still very primitive machinery, you see. Qubits are delicate, and they are easily perturbed by temperature or vibration. Noise is common. It may be as simple as hardware restrictions providing the illusion of something out of the ordinary. However, the thing that keeps people up at night here is what many people would say. What is it that is causing the noise? What could happen is that such anomalies are some tiny clue to new physics interactions between the Higgs field and places in reality that we have never observed. Think about that for a moment. Even a computer that has been constructed to compute has simply bumped into something that cannot be calculated. This is why certain researchers are reserved and others are enthusiastic. This is what they are actually referring to when they say God particle protocol, the feeling that our technology is pulling away the very thread of reality. And it gets stranger. The debate over the existence of these anomalies has leaked out of the laboratory and into the broader field of the scientific community, and the speculation it is generating is more like a science fiction story. One of the theories that are going round links these fluctuations with the many worlds interpretation of quantum mechanics. That is what they mean by the fact that whenever a quantum event takes place, the universe forks, forming parallel universes. Assuming that is so, then what happens when the noise in the data is really noise? But what about the fact that it is the slightest imprint of some other strand of reality touching on our own? It may seem preposterous, yet this is not the first instance that physicists have been keen on considering the existence of more than one universe. Brian Cox himself has speculated publicly on many worlds, noting that quantum mechanics as a mathematics not only does not prohibit it, but even can require it. When you put these startling quantum processor outcomes with the warnings made by Cox, you begin to perceive why the term God particle protocol has become so popular. It gets that disturbing thought of us likely triggering a frontier, which is not supposed to be tapped this early. Let's make this interactive. What do you think? Suppose that quantum computers were picking up evidence of parallel realities. Should we go to it? Or shall we close a door behind? Comment in the foregoing before we unveil what some scientists believe could actually be the case. However, as curious as it would be to discuss the concept of multiverses, the anomalies themselves are curious. Is the Higgs field yet more complicated than we supposed and harbors hidden layers or companion particles, which can only manifest themselves through the special spectacles of quantum computation? Some theorists believe so. They cite the fact that there could be unknown scalar particles that are cousins of the Higgs that could be used to solve the dark matter mystery or the matter-antimatter imbalance in the universe. When quantum computers are already beginning to see them, then maybe we are as close as ever to writing new laws of physics. And this is where the tension is created. Since when you believe that it could be that something has gone wrong, you know that it has some implications, not only to science but also to our standing in the universe. Unless the Higgs is stable, whether it can fluctuate in a way that we have not yet understood, then reality itself may be on a knife edge, a cosmic system that, in certain circumstances, could fall over into something completely new. This is where the term God particle protocol, which may not be a red button to terminate all of humanity, but rather the boundary between human technology and the most fundamental reality structure. We are no longer simulating physics. We can be touching it. And that is where the voice of Brian Cox comes in, as in his lectures, interviews, and books. He has cautioned us about this exact moment, the merge of technology and quantum fields and cosmic stability. And when Cox asks those questions, the world takes his note, which leads us to the second chapter of our story. Brian Cox himself and what he has actually been saying by this collision between the Higgs boson and the emergence of quantum computing. People listen when Brian Cox is talking. It is not only due to the fact that he is a respected physicist who contributed to the Atlas experiment that initially discovered the Higgs boson, but because he has a rare talent to be able to translate cosmic complexity into human language. And his keynote in June 2025 will be a talk that will link three of the most enigmatic concepts in modern-day science: quantum computers, black holes, and the very boundaries of reality. This message by Cox was thought-provoking and encouraging. He described the fact that once we take technology to extremes, be it particle colliders or quantum processors, we will no longer be merely crunching data, but rather we will be on the fringes of reality itself. Black holes, Higgs fields, quantum entanglement, these are not distinct trifles. They are the strands in an extremely bigger tapestry, and quantum computers could be the needles that weave them together in ways of which we have not yet had the slightest idea. Among the most controversial arguments that Cox presented was that he was fascinated with the many worlds interpretation of quantum mechanics. It is a radical notion that all quantum choices, all the particles taking the left rather than the right, all the atoms taking the decay path rather than the decay route, all of that does not simply occur here. It happens in parallel. All possibilities splinter into their own universe, all possible versions of reality, all coexisting simultaneously. Now then, we have to be clear that Cox does not mean that we open up other universes tomorrow morning. What he means, however, is that the same math that we apply to explain the Higgs boson also allows us to have multiple realities living peacefully together. This is why his warnings have been related by so many people to these new quantum experiments. Since once machines begin retrieving results that do not conform to predictions, many worlds is no longer a simple thought experiment any longer. To Cox, it is not merely chimerical conjecturing on the part of the armchair. Higgs boson is an evidence that everything we can see is brought into being by invisible fields. Supposing the Higgs field is capable of ripple, why not other fields? Can it vary? And might the variations be the borders between realities? These are the types of questions which, according to Cox, render physics as the nearest thing to a philosophical text which is written in formulas. Just to refresh our memories, halfway through the argument is that quantum computers have made the God-particle protocol come to pass. We have now observed the reason why that is not pure an idea.